If you are writing a thesis or research paper, sooner or later you will reach the data analysis section. This is the stage where you have to choose the right statistical test. Before we begin, what is a variable? Before learning correlation and regression, you first need to understand one important word: variable. A variable is simply something that can have different values. It is the information that a researcher collects during a study. For example, you are conducting research to study whether the number of hours patients sleep is related to their blood pressure. In this study, sleep hours are one variable because every patient sleeps for a different number of hours. Blood pressure is another variable because it is different for each patient. What is correlation? Correlation is a statistical method that helps researchers find out whether two variables are related. Correlation answers only one question: do these two variables change together? It does not tell you that one variable is changing the other. It only tells you whether there is a relationship between them. For example, your research question is customer satisfaction related to customer loyalty? Correlation checks whether customers who report higher satisfaction also tend to be more loyal. If they do, there is a relationship. Notice that in this example, the researcher is not trying to predict anything. The researcher only wants to know whether a relationship exists. What does the correlation result mean? After running a correlation test, statistical software gives you a single number called the correlation coefficient. This number ranges from -1 to +1. If the value is close to +1, the two variables increase together. For example, if customer satisfaction increases, customer loyalty also tends to increase. If the value is close to -1, the variables move in opposite directions. For example, as waiting time in a hospital increases, patient satisfaction tends to decrease. If the value is close to 0, there is little or no relationship between the two variables. Correlation does not mean cause and effect. Finding a relationship does not mean one variable is causing the other. For example, your research finds that hospitals with more nurses usually have lower patient death rates. This does not automatically prove that increasing the number of nurses alone reduces death rates. Those hospitals may also have better equipment, more experienced doctors, or better treatment procedures. Correlation only tells you that the two variables are related. It does not prove why they are related. That is why researchers should avoid writing statements such as X causes Y, when they only use correlation analysis. What is regression? You can watch above linked video to learn how to perform regression. Regression is another statistical method, but it does more than correlation. Instead of only checking whether two variables are related, regression examines whether one or more variables can explain or predict another variable. Regression answers questions like, if this variable changes, how much will the other variable change? This is why regression is commonly used when researchers want to build a prediction model. Regression always has two types of variables. The independent variable is the variable that is expected to influence another variable. The dependent variable is the outcome that the researcher wants to explain or predict. For example, your research question is, does advertising spending predict monthly sales? Advertising spending is the independent variable because it is expected to influence sales. Monthly sales are the dependent variable because they are the outcome you want to predict. The independent variable is the possible predictor. The dependent variable is the result you want to predict. What does regression do? Regression creates a mathematical model that predicts the value of the dependent variable. If your research shows that increasing advertising spending usually increases monthly sales, regression does not stop there. It estimates how much sales are expected to increase for every increase in advertising spending. This is the main difference between correlation and regression. Correlation tells you whether there is a relationship. Regression estimates the size of that relationship and uses it for prediction. How do you decide which one to use? Researchers usually perform correlation first and regression second. Step 1 is correlation. Researchers first check which variables are related to the outcome. For example, a researcher wants to study customer satisfaction. The researcher collects data on service quality, product quality, delivery time, and price. Correlation is first used to see whether each of these variables has a relationship with customer satisfaction. The results show that service quality, product quality, and delivery time are related to customer satisfaction, but price is not. The researcher then moves to step 2, regression. Regression is used to find out which variable is the strongest predictor of customer satisfaction and how much each variable contributes after all the important variables are analyzed together. The results can show that product quality was the strongest positive predictor of customer satisfaction, followed by service quality. Delivery time had a significant negative effect on customer satisfaction. So, you can remember it like this: correlation helps you find relationships, regression helps you find the best predictor and build the final prediction model.